In this video, I'm going to show you how to find the inverse of a square matrix, and the example that we're going to do is a 3 by 3 matrix. If you have a real number A, then its multiplicative inverse is A inverse, and the following is true: A times A inverse equals 1. So for example, 3 times the multiplicative inverse of 3, which we usually write like this, equals 1. I could also write that as 3 times 3 inverse equals 1. So we know that works with real numbers, and the definition for the multiplicative inverse of a matrix is very similar. If I have the inverse of a matrix, then it has to be true that if I multiply my matrix times its inverse, I'll get the identity. And it must be commutative. I need to multiply it in the other order as well. So we call this the inverse matrix of A. So just to show you how this works, if I have two matrices and they're inverses, then what has to happen is if I multiply them in both orders, I will end up with the identity matrix. So let's see how to find the inverse matrix. So now let's say I've got the matrix A, and I need to find this mystery matrix B, and what has to be true is if I multiply A times B, I'm going to get the identity matrix. This has to be true if A and B are inverses. So if I run through the multiplication of the two matrices, and if you remember, the way we do that is we multiply the row by the column to get each of the spots. So now this matrix right here, this is going to be my product A times B. And we know that that has to equal my identity matrix, which is 1, 0, 0, 1. Now when we have two matrices that are equal, that means the corresponding entries would be equal. So that gives me 4a plus 5c equals 1, 7a plus 9c equals 0, 4b plus 5d equals 0, and 7b plus 9d equals 1. Now if you notice, these two equations have a and c in them, and these two equations have b and d. So I'm going to take these two equations and put them together in a system, and I'm going to put these two together in a system. So here are my two systems, and I've taken each of the systems and I've written them as augmented matrix, and I've solved them to get a equals 9, b equals -5, c equals -7, and d equals 4. That means our mystery matrix is actually 9, -5, -7, 4, and that is A inverse. Now before we go on, I want you to notice that the coefficients for both of the systems is 4, 5, 7, 9. So I could feasibly put those together and solve them simultaneously if I put both of these columns in for the constants. So here you can see those coefficient values, and now I've taken the two columns that were my constants and I put them both in the matrix, and I'm going to solve them simultaneously because it would be the same exact row operations to solve both of them if I had them separate. So here's the bottom line. If you take your matrix of your coefficients and you join that with the identity matrix and you do row operations until what used to be A is now the identity matrix, then what appears on the right will be the inverse of that matrix. So here's how you find an inverse matrix. You're going to form an augmented matrix so that what is on the left is your square matrix and what is on the right is the corresponding identity matrix. Then you're going to transform the left into the identity matrix, and that what's going to happen is that the matrix that you have on the right side when you finish will actually be your inverse matrix. Okay, here's an example. I've got my matrix A and I want to find the inverse. So I've got it set up so that I have my A here, and this is my identity matrix. and it's 3 by 3. So I need to work on that with my row operations. So what I'm going to do first is I'm going to take -1 times this row, and then I'm going to add it to the first row. So if I multiply through by -1, I get -1, 0, -2, 0, -1, 0. Now the row that's not involved in this transaction needs to stay, so I've written down 236001. Now of the two remaining rows, one of those is going to stay and the other is going to be replaced by the sum. Now since the second row has a 0 in the second position, I'm going to keep that one and I'm going to replace the second row with the sum. So that's going to give me 0, 2, 2, 1, -1, 0. Now to get rid of the 2 in the bottom, I'm going to take the top row and I'm going to multiply it by a -2, and I'll add it to the bottom row. So when I multiply through by -2, I get -2, 0, -4, and 0, -2, 0. Now since the second row isn't involved in this transaction, I've just copied it down as it is, and I'm going to leave the first row 102, 0, 1, 0, and I'm going to replace the third row with my sum. So that's going to be 0, 3, 2, 0, -2, 1. Now to get rid of one of the entries here, either the 2 or 3, I'm going to have to double multiply. So I'm going to multiply this row by -3, and I'm going to multiply this row by 2, and then I will add those together. So when I do that, I get 0, -6, -6, -3, +3, 0, and then for the second one, I get 0, 6, 4, 0, -4, 2. Now I've copied over the top row because it's not involved in the transaction, and I need to pick one of the second or the third rows to carry over, and I'm going to keep the second one. It doesn't really matter, I just need to keep one of them. And now the third row is going to be replaced by the sum, and that's going to be 0, 0, -2, -3, -1, 2. So now I've got my 2 zeros in the first column, and I calculated to get a 0 in the second column in the bottom, and I've already got one in the top, so I can go ahead and move on to the third column, and I'm going to get rid of this 2 in the top row by just simply adding it to the third row. Now I've copied the second row because it's not involved in the transaction, and I'm going to leave the third row as it is, and I'm going to add the first and the third row and replace the top row. Here's my 1, 0, 0, and then -3, 0, 2. And now looking at this last 2 that I have to get rid of, it looks like I could add the second and the third equations, and that would take care of that number. So I've written down the first row because it's not involved in the transaction, and I need to pick one of the other 2 rows to stay, and I'm going to leave the third row, and I'm going to replace the second row with the sum of the second and the third rows. So when I add those together, I get 0, 2, 0, -2, -2, 2. Now it looks like I'm pretty much done, except for I have a +2 here and a -2 here, and I need them to be 1s. So I can take care of those by doing some multiplication. I can multiply this row by 1/2, and I can multiply this row by a -1/2. As I multiply those through, I get 0, 1, 0, -1, -1, 1. And for the last row, I get 0, 0, 1, 3/2, 1/2, -1. And because this is now my identity matrix, that means that this is the inverse matrix of A. Okay, here you see my augmented matrix with A on the left and the identity on the right. So we're going to work with the left side and get it into reduced row echelon form. So the first thing I'm going to do is I'm going to multiply this row by -2, and I'm going to add it to the third row. So when I multiply through, I get -2, 0, -4, and then 0, -2, 0. Now you can see I've copied over the first row because it's not involved in the transaction, so it stays. And then I'm going to keep the second row, and I'm going to replace the third row with my sum. So that's going to be 0, 3, 2, 0, -2, 1. Now when I look at that, I need to get rid of this other 1, so I'm going to multiply the top row by a -1, and then I will add it to the second row. So -1, -2, -4, and then -1, 0, 0. So now I've left the third row, and I'm going to leave the first row, and I'm going to replace the second row with the sum. And that's going to give me 0, -2, -2, -1, 1, 0. Now that I have these two zeros in the first column, I need to move on to the second column. And I need to get a 0 here and here. So I think I'm going to start with the top row. It doesn't matter, you can do whichever one you want, but I'm going to start with the top row, and I'm going to add this row and this row together because I already have opposites. Now I'm going to leave the second row as it is, and I'm going to replace the top row with the sum. So that's going to be 1, 0, 2, 0, 1, 0. Now I'm going to key in on getting rid of the 3, and to do that it looks like I'm going to need to double multiply. I'm going to multiply this row by 3 and this row by 2. So when I multiply the top row by 3 here, I get 0, -6, -6, -3, 3, and 0. When I multiply the bottom row, I get 0, 6, 4, 0, -4, 2. So now I need to choose one of the two rows to leave. I think I'm going to leave the bottom row, but I'm going to move it up. And I'm going to put the sum in the third row. So that's going to be 0, 0, -2, -3, -1, 2. So now I've got 2 zeros in the first column. I've got my 2 zeros in the second column. So I need to work on the third column. And since those are all 2's, this should be pretty straightforward. So to start out with, I'm going to add this row and this row. The middle row stays, and I'm going to let the last row stay. And then I'm going to add and replace the top row. And I'm going to get 1, 0, 0, -3, 0, 2. Next, I'm going to add the second row and the third row. I'm going to leave the first row, and I'm going to leave the last row, and I'm going to replace the second row with the sum. So 0, 3, 0, -3, -3, 3. Now it looks like I have my two triangles of zeros, so all I need to do to finish this is to get 1's in these two places. So I'm just going to multiply this row by 1/3, and I'm going to multiply the bottom row by -1/2. I'm going to get 0, 1, 0, -1, -1, 1, and for the last row I'm going to get 0, 0, 1, 3/2, 1/2, -1. So I'm going to move this up just a little bit, and you can see here that this is now the identity matrix, and this is now our inverse matrix. So our inverse matrix equals -3, 0, 2, -1, -1, 1, 3/2, 1/2, -1.